Alright, here are a few questions. First of all, how do you read something like this? What does each of these numbers mean? And then second of all, we're going to talk about can you use these numbers to find the standard deviation of the entire sample. So first of all, let's look at reading this. These are the sum of the squared deviations. So I'm looking at the difference of each individual. Well, actually, let's look at this one. This is the total. So this is, I'm going to take the difference of each individual from the grand mean, the mean of the whole sample, all 15, the mean of all 15, square them each, and then add them all up. This one, instead of looking at the difference between individuals and the mean, what I'm looking for is differences between little local x bars and the grand mean. I'm going to see how far local x bars are away from the grand mean. Since each of these x bars actually refers to 5 individuals, I multiply those differences by 5 first before I add them all up. Oopsie. And don't forget, you square them first. Square them first, multiply them by 5, and then add them all up. That's this. That's the sum of, that's SS. That's the sum of squares for groups. This is the sum of squares, sorry, it's SSG I should say, and this is equal to SST, the sum of squares for the total. You can see why it's called sum of squares. And this is the sum of squares error, which basically means anything that isn't picked up by this, that still is in the error. Technically what it is I'm taking each of the local xi's and I'm subtracting that from the grand total xi. That's equal to SSE. But you can just think of it as this subtract this. It's always going to work out. And the degrees of freedom are going to work out that way too. There are 15 total things in total, so there are 14 degrees of freedom for the individuals. There are 3 groups, so there are 12 degrees of freedoms or 2 degrees of freedoms for the groups. Because the degrees of freedom all have to add up, that means there must be 12 degrees of freedom for the error. Another way to think about that is I've got 4 degrees of freedom here, each x bar minus its local, each x minus its local x bar, 4 degrees of freedom here, and 4 degrees of freedom here. Altogether, that's 12 degrees of freedom for the total of all the error. So I hope that helps you in trying to figure out how to read this darn thing.